Recorded is rolling. It is Tuesday, April 7th. We're doing lesson 10.6 today, conditional probability. This is the last lesson of module 10. Tomorrow I'll do Kahoot review with you guys. Thursday will be an Alex day, which you have an Alex assignment open 25 and 6. So you guys had a good head start on that yesterday. And I'll get you guys the module 10 quiz Friday, which of course is going to look a lot like this that we'll do tomorrow. Before I get too far into that, we got a play coming up this weekend. Got the 9th, 10th, 11th. Want to do that? Got school play. School play. Okay. All right. So, what is conditional probability? I'll show you guys this diagram and how to read and interpret this, and then we'll go for that. So, maybe you have events A and B, and it looks like these are not mutually exclusive because you could have A and B, so that could happen too. Okay. All right. But do you guys see this notation here? And some of you guys saw this on Alex, and you were wondering what this was with this bar in the middle. You guys see this vertical bar? PB bar A. Right? The way you read that is probability of B given A. So you're told that A happened. And now that you're told that A happened, what's the probability of B also happening? You guys get that? Okay, so B given that A, well, is a given. Okay. Well, if you look at the Venn diagram, you can, I think, make sense of this. So if I tell you that A happened, can't you just narrow down the possibilities to that ring right there, which is marked A? Right? And if I say, what's the probability that B happened given that A happened? Isn't it basically the probability of this wedge happening given that circle A? Right? So I think it's this wedge divided by this entire circle. Wouldn't that be B given that A happened? You guys see that? Okay. Right. And how do you write that out with math notation? It would be like this. It's probability of A and B, that intersection right there, A and intersection B, divided by probability of A, which is the same thing I was just pointing out. You guys see how it's the same thing? Right, so probability of B given A is probability of A and B divided by the probability of A. Right? Now there's one more idea in this chapter, which is independent events, but let's just do one thing at a time here. Just one thing at a time. Okay. This lesson's a bit shorter. They didn't ask a whole lot of questions of that, so here. I'll just do a few of these with the guys. Okay, so make sure your name's on your paper. Guys, is your name on your paper? Okay, your name's on paper, so when you turn this in a few minutes, I know who to give the points to. We'll do lesson 10-6 notes. Okay, so you guys got your name, you guys got lesson 10-6 notes. Okay. Let's do the book examples. Right, so there's really only two main examples to do. So first example 1. There are currently 16 customers in line at the deli counter, and they have tickets that are numbered 179 to 194. Okay. So 179 to 194. Let's say they're all sequential in order. Okay. Guys, first question for you guys. Are there an even or an odd number of tickets floating around in this line? What?
No, I guess I have to ask.
Here, guys, look here. Let's start counting. What if I start from the number 1? And I do 2, 3, 4. Is that an even or an odd number? What? Guys, 4. 4 is an even number, right? You guys see 4 is an even number?
Yeah.
Okay. So if you start on an odd number and you end on an even number and you have all the numbers in between, then in general you could say that's what an odd or an even set of numbers. Even. Hey, isn't that what we have over here? We start with an odd and end with an even. So are there an odd or an even number of tickets? Even number of tickets.
Yeah.
Right. Here, let's write out the sample space. So there could be 179, just ticket 180, 181, 2, 3, 4, 5, 6, 187, 188, 189, 190, 91, 192, 193, 194. 2, 4, 6, 8, 10, 12, 14, 16. Is that 16 tickets?
Sure.
Right? Yeah, so that's an even number of tickets. All right, so back over here. Naveen will help customers holding tickets with even numbers, and Ellie will help customers holding odd numbers. Oh, well, guys, if they split it up even and odd, then don't they each have half the total tickets to work with? Which would be 8 and 8, wouldn't it? So Naveen is helping 8 customers, and Ellie is helping the other 8 customers. Is that true? Okay. So if a customer is helped by Naveen, Naveen was doing even numbers. So let's circle all the even numbers for Naveen. Here's all the even numbers for Naveen. Then what is the probability that the customer is holding ticket number 190, which is this one right here, ticket number 190? Okay. So probability of ticket number 190, given that you're helped by Naveen, maybe I could write it like that. Okay. Would be, what do you guys think is the answer?
Wait, no, you knew it even a lot.
Yeah.
Naveen's doing evens.
1/8.
More than 100.
Yeah, it'd be 1 out of 8.
A kabillion.
Guys, Naveen's helping 8 people, and one of those happens to be holding the ticket number 190. So it'd be 1 out of 8. Okay. 1 out of 8. Okay. All right. Example 2. Okay, interpret independence. So this we haven't covered yet, right? But let's look at this table here. We got a table. Okay. We got different degrees and we got different associated incomes. Kind of hard to put up to the screen. Okay, I think that works. Okay. Right, so there's a bunch of people working at this company, and some of them have bachelor's degrees and some of them have master's degrees. Okay. And then we got these different incomes and we got the full table. Right? So we got like a low income, a medium income, and a high income. Let's call it that. Okay. Okay. Now, guys, if you have a bachelor's degree, are you more likely to have a low or a high income at this company? Low. Right? You guys see it's like low income is like 26 of them there. Right? There's only like 3 of them with bachelor's degrees that actually have a high income. But if you have a master's degree, what are you more likely to have, a low or high income? It looks like a really high income because there's like a bunch of these people have high incomes with master's degrees. Right? Right. So the question they're leading up to is this one right here. Are the events of a worker having an annual salary of over 65,000, so we'll call it high income, okay, and also have a master's degree, are those independent events? Is that right? Question, independent events, right? Now, based on what we just walked through in your observations, would you say that that's okay? It's just totally random. It's completely independent, or we say no. I think there is a correlation between having some degree and having some income. What do you guys think makes more sense?
I think the dependent. The latter.
Yeah. Second thing I said, dependent. Yes, I think these would be dependent. So how can we show that mathematically? What's the mathematics? Okay. And the mathematics is up here in this paragraph right before the example. It says, we would say that events A and B are independent if the probability of A given B equals the probability of A, and the probability of B given A represents is equal to the probability of B. Or you could write it in this notation. Probability of A given B is the exact same thing as probability of A. Okay? Because once you're given B, this is assuming that it is independent, or if this just does check out, it would be independent. Then it doesn't matter if B is true or not, the probabilities would be the same. Or you could switch and go backwards. You say the probability of B given A is the same thing as probability of B in general, regardless of if A is true or not. That would be independent. Okay? But I don't think that's the case here. So let's set up an equation that looks like that. Right, so example 2, I'll say independent. I'll put a question mark. Okay? So let's call event A is let's say having a master's. Okay, so event A is having a master's degree. Event B represents I'll say a high salary. Like over $65,000. Okay. So what's the probability of B given A versus what's the probability of B? Because if these were really the same, then you say, oh, actually, these are independent scenarios, right? But I don't think these are going to be the same. Or we could switch around. We could say, what's the probability of A given B? And then what's the just probability of A? And say, probability of A. Okay. And if these were the same, then that would also represent independent. Okay. But I don't think these are going to be the same as each other. And I also don't think these are going to be the same as each other. Because we said, well, it looks like there's definitely a correlation between having a higher degree and having a higher salary. Right? Okay. So let's go to the table and get some numbers for these. What number is this, and this? Right? So probability of having a B given A. So if you have a master's degree, that is event A. Okay. So we're just going to focus on. Sorry to get this on the screen here. Okay. We're just going to focus on this column because that is given A. You guys get that? Given event A is having a master's degree. Okay. And high salary is 39 of these people. 39 out of the 62 people who have masters. Do you see that? Right? It's okay. 39 out of 62 of those people have a high salary. That is the probability of having a high salary given that you have a master's. It's 39 out of 62. And to turn that into a decimal or percentage, so we can do a faster comparison, this works out to a point, I'll round it to 0.63 or 63%. Okay, right, that right? Okay. Now, what's the probability of B, which is just having high salary in general? So if you looked at all the employees in the company having high salary in general. Okay, so how many total employees have the high salary?
42.
42. And how many employees work there altogether? 100. So would it be, in general, 42 out of 100 workers have a high salary? And that's called 0.42 or 42%. Okay.
That'd be probably.
Yeah, see how those are definitely not equal to each other? Okay. That means that these are not independent events. Right. Which again, we kind of intuited from the start anyway, but there's the math to back it up.
Wait. Oh, yeah.
Right. Now let's look at it in the reverse. So this actually we could have done what we're about to do, which is just reverse everything. Okay. So what's the probability of A given B? Let's say what's the probability that you do have a master's given that you have a high salary? So what we're going to do is we're going to take all the high salary employees, we're going to bring them all into a room and say, okay, everybody in this room now has a high salary. How many of you guys have masters? You guys get that? Okay, so let's get high salary, which is now this row. Now we're not looking at columns, we're looking at rows. Oh, guys, how many people have a high salary in this company?
42.
42. And how many of the 42 have masters?
39.
39. Almost all of them. Oh, 39 out of 42 of the high salaries also have masters. So what's 39 out of 42? That's 0.93 or 93%. Which again, almost everybody. So if you have a high salary, almost guaranteed you have a master's to get there. Finally, what's the probability of having a master's in general? So how many employees have masters?
42. Or
60.
62. 62 have masters out of 100 employees total. So 62 out of 100 have the masters. That's 0.62 or 62%. Okay. And same thing. These were never going to be equal because we looked at it from another perspective and they weren't equal. So the fact these are not equal, also not independent events. Okay. You didn't necessarily have to do both of these analyses, but they do align with the outcome. Okay. Guys get there? And that's the only two examples the book does. And so to recap what we got, we're looking at okay, conditional probability. Okay. So probability of B given A. Okay. So B given A is like you focus on the A circle, and then B given A would be this wedge right here. Okay. And as a probability, you can take the ratio. And that works out to the intersection of A and B. So A and B divided by the probability of A in general. Which is like spelled out here. And the other main thing that you guys learned today is are events independent? And the test for independence is on page 225. Is this little blip right here? Is what we just followed, right above the example. Okay. Is if the probability of B given A and probability of B in general, if those were the same, like if I got 63% and well, pretty close to 63%, it's like between 60 and 65, I say, well, it's basically the same thing. We'll call that independent. Okay. Or vice versa. A given B and probability of A in general, if those were also the same number, pretty close to each other, I say, well, that's basically independent. But the example we saw is they are not independent events. Right? You have the higher salary, you have a higher degree. Right? Those are highly correlated. Right? Right, you guys good?
So if you bracket A equals B, then it's independent. Or is it
Yeah. Like if these numbers were the same, like 63% and let's say 62%, say, well, those are almost the same, it's probably independent. Or if these numbers were the same, if I had like 93% and 93%, say, well, those are the same. Right? That would indicate an independent event, which would mean that having a higher degree has no relationship with having a higher salary. Yeah, dependent, right, is exactly what you're looking at here, where the numbers don't match.
I was thinking that.
You're looking at the math back up that if you have a higher degree, that would be correlated with also having higher salary.
That me like it.
All right, so guys, double check, make sure your name is on your paper. I think it should cover any question that Alex asked you about that lesson. And then turn that to the gray tray. I'll give you guys points.